Okay, now welcome back to this tutorial. The thing that I just want to talk about that is this. Imagine that you have, let me choose the color. Imagine that, for example, you have designed a machine. I'm just going to show this machine like that. That's a machine. That you say that you can just, for example, if also I'm just going to draw a kind of a cartoon. My drawing is not so great, but that's for the sake of, I should say, demonstration. Imagine that the purpose of the machine is that if you, for example, it's going to be you, I'm just going to name this myself as my own name. I'm just going to call that me. It's me standing here. Imagine that I say that, okay, with this machine, how this machine works is like that. I'm just going to feed myself into this machine. But what happens outside, what is going to be the output of this machine if I'm just going to be the input for this machine, is that it essentially produces the same person, which it should look like exactly like me, which is going to be that essentially a copy of exact me. That's the example which I have for demonstration. I say that, okay, if I feed myself as an input to this machine which I have created, I have designed it myself, I have been the engineer to design this machine, it's going to produce the same me, the exact copy of me. Okay, that's the thing which I claim, and I just say, okay, that's my invention. But at the same time, I say that, okay, I'm just going to recruit volunteers to come over here, and they feed themselves to just go under the machine, and we see the output, which is going to be, for example, that person. For example, I recruited, for example, George as a volunteer. That George goes under this machine, and I should have George on the other side of, I should say, an output of my invention. But very logically, George, before he just wants to just go undergo this transformation process, George may come and say, okay, no problem, I can just do that, but what if you just undergo this process yourself? You become the first volunteer and see that if you yourself go under this process, you end up with the exact copy of yourself before I just go to run the experiment on my own, before I just submit myself the risk of this experiment and this transformation. That's a very legitimate claim, and that's gonna be the thing which I'm just gonna talk about this tutorial. I just create a machine, I create a model which I claim it's gonna do something like that, but before I just go to predict other models, I'm just gonna go ahead and see if I can just create my own self. I'm just gonna take this example which I have just given that to you right now, to just go ahead and say go to the next, I should say next page, and relate this to the thing that I'm just going to do it right now. Imagine that I have these Cartesian coordinates which I have two axes. One of them is going to be, for example, represents the x1, and the other axis it's going to represent the x2. They are just going to be the variable of my model. And imagine that I have come here and said that I have some random points which they are the outputs of maybe some functions which I have no idea what they are. And the thing which I do is this. I come here and I model these points with this line. Essentially, that's going to be my regression line. That's going to be my regression. Linear, which is a linear function. Which is going to be a linear regression for this model, which you can see that, for example, you can say that y equals to ax plus b. For example, that's going to be the model which I created. I say, okay, I come here to make some inferences about this model, and my inference, I count with the value for the A, which is going to be my slope, and I count with the value for the B, which is going to be my intercept. Then I say that for any other points which I can think of, for example, if I say that if this model represents these scatter points here on my x1, x2, I should say, plane, then I say, okay, if then as a result, if I come with one point here, a random point, which it has, let's say, for example, of the coordinates x1 here, then you see that with this regression line, you can claim that, okay, this point it's just going to come and it should have, for example, this value as a predicted value of that. I'm just going to say that x hat of 2. That's essentially become the purpose, one of the purposes about the inference that we make by using a kind of a regression model. We have not talked about the causal inference. We are talking about the prediction, which is going to be the result of our inference of these models. But before we just come here and let's say talk about these values, these things, we say, okay, how about if with the model which I have created, I call the model which I have created as a delta here. How about if I imagine the model which I have created and I call this regression line a delta? How about if I assume that there is no points left? I keep my model there and I just, for example, remove the points which I have and see that, okay, what happens if I use the same model which I have created based on these models to see that if I can produce the same points by the same model. It is essentially, it's going to be like the examples that we had. We said that the machine which I have created and invented, and I said that this machine is able to produce, for example, takes you as an input and gives another replicate, a copy, exact copy of you, then I say, okay, before I just go to recruit volunteers like George, to just produce a George, let's see how much this machine which I have created is accurate if it can just produces me as an inventor of this machine. And here we have the same story. We said that let's see the model which I have created here, the regression model which I have created. Let's see how this model is capable of accurately producing these exact points which they have generated this model itself. Imagine that, for example, I can create with this model, I can create this point, I can create these points. For example, this point is going to be exact itself. This point is going to be this point. This one is going to be with this, I should say, marginal error. This one, and you see that these points and this one exact itself. You see that now I can say that, okay, because the variations that I see from the original points with respect to, let's say, the model which it has been replicated with this delta machine here is marginal, and in some cases like this, they are the exact same thing. I can have an idea of how this model which I have created as a linear regression is going to be accurate. Then I can just rely on that. If I say come here with, for example, another point, for example, this point, I call that point, for example, gamma, that you see that how my prediction is going to be, let's say, legitimate when it goes under this machine as a transformation to just have a prediction, for example, as this point from this. And essentially, it was a kind of an intuition of the check that we are just going to do with this model, and that's an intuition. And I'm just going to show you that when we just go back to the R, we're just going to talk about, I should say, a function which is called PP check, which stands for the predictive posterior check. That from there we are just going to run our example on the things which you have done so far to see that how this intuition can be translated with this mathematical and scientific language in R to give us a good inclination of how the model which we have created is capable of accurately predicting the future of the future observation.